Terms of equations word problems, we don't have the equations set up, so we need to set them up ourselves. In order to find out what our variables are, the first thing we should look at is we should look right down here at the solution, and we see we're being asked for chefs and customers. Therefore, our variables must be it must be chefs and customers. So we're going to assign X for chefs and Y for customers, and we're going to go from there. Okay, so let's read the problem right here. Each chef, so each X at Sushi Emperor, each chef prepares 15 regular rolls and 20 vegetarian rolls daily. Okay, so there's two different things going on here for the chef. On Tuesday, each customer ate 2 regular rolls and 3 vegetarian rolls. So again, two different things going on for the customer. By the end of the day, we've got 4 regular rolls and 1 vegetarian roll uneaten. So let's take a look at what's happening here. We can see there's 2 separate things going on in each instance, and it would make sense that if you look at it, you've got your regular rolls going on here, you've got your regular rolls going on here, you've got your regular rolls going on here. So it makes sense to keep the regular rolls going in one equation, the vegetarian rolls in the other equation. Okay, so we'll see our regular rolls. We've got 15 regular rolls made by each chef. So we've got 15 regular rolls made by each chef, and we've got 2 of those eaten by each customer. All right, we've got 2 of those eaten by each customer, and as a result, there were 4 remaining. Okay, and then if we look at the vegetarian rolls, we started with 20 vegetarian rolls made by each chef, and we take away 3 of those eaten by each customer, and that as a result we had 1 left. Okay, and that's where we're getting all of those from. Okay, so there's our equations, our linear equations set up right here. There's a few ways of doing this. We could probably multiply each equation by the other side of the equation to try and eliminate. Would probably be one way to do it. We could also subtract the entire equation from another. I like that idea. I haven't shown you that before, so I'm going to show you that. We're actually going to subtract, and I'm kind of going to do this in reverse. I'm going to subtract the 20 from the 15, or the 15 from the 20, so that gives me 5x. And then 2 minus 3 is going to give me, or negative 3, sorry, rather, negative 3 minus negative 2 is going to give me negative 1. So negative y, right, is equal to, and then we've got a 1 minus 4, which is giving us negative 3. Okay, so all I've done here is I've actually just subtracted in reverse. I'm trying to get I'm trying to get the x smaller here. Now, the reason I'm trying to get the x smaller here is because I recognize that 5 is a common factor for both of these equations. So what I'm going to do now is I'm actually going to multiply this new equation times, well, 3 or 4, whichever one you like. I'm going to multiply it by 3 so that I can work with the first equation. Okay, so this is now going to give me 15x minus 3y is equal to negative 9. So I've got another equation now that I can work with the first equation with. So I'm going to bring my first equation back down so that we can look at the two together. So 15x minus 2y is equal to 4, and 15x minus 3y is equal to negative 9. So when we do a little bit of elimination here, we cancel out because we're going to subtract. We got 3 minus negative 2 is going to give us y, of course, positive y, so it's 3. Negative 3 is going to give us negative y. And we've got negative 9 minus 4 is going to give us negative 13. So therefore, y must be equal to 13. Right? So all I've done here is I've solved for y. And there's multiple different ways of doing this. I kind of like this way because it's showing different things that you can achieve with your equations. Once you have your 13 customers, you can plug your 13 in anywhere you like. So again, working off the first equation here, we can say, okay, 15x minus 2 times 13 is equal to 4, and therefore 15x minus 26 equals 4. So adding 26 to both sides of the equation is going to give us 15x equals 30, and this makes a lot of sense. X equals 2. Okay, so I hope you followed that whole process. Again, there's multiple different ways of doing this. There's multiple different ways of doing this whole part of the problem. What I did is I subtracted them, but of course there's no reason why you couldn't also say multiply each equation by the other variable, so the other coefficient. So if we were to multiply this equation here times, say, the 3 is easier than the 20, so if we multiply this equation here times 3 and this equation here times 2, we then get 3 times 15 is, of course, 45x, and 3 times negative 2 is negative 6y, and 3 times 4 is 12. And then we got 2, we got 40x minus 6y equals 2. And again, you can see where this is going again. So this is going to give us now 5x. We're going to be subtracting them, of course, because these are the same sign. They're going to cancel out. 5x is equal to 10, which means that when we divide both sides, we get x equals 2, and you can see it's the same thing we've got right here. X equals 2, and when we have x equals 2, we can then plug in the 2 here into one of the equations to solve that way. So as you can see, there's multiple ways you can solve these questions. You can perform any operation you like on entire equations the same way as you would on any given expression. So I'm going to leave you with that, and hopefully the rest of the questions shouldn't have any problems for you.